Hi, Omar from Episode here. In this video I'm going to show you how to run a flow study optimization in Cortime. For this we're going to use this revolve pipe that we have here. As it can be seen, it has an incision in the middle part that is created by these two mirrored splines. If we use this section view tool, we can see how the pipe looks from the inside. Before we set up the flow study, we have to make the pipe watertight. And we do that by adding this SolidWorks tool called lid. So we add one on each side to make it completely enclosed. Now we can take a look at the flow study. In it we have set up two boundary conditions. First, static pressure in one side, and second, static pressure in the opposite side. There is 1 bar of difference between the two. Then we have set up three goals. A surface goal of static pressure in the first phase, surface goal of volume flow rate in the first phase, and then a surface goal of static pressure in the second phase. So now that we have set up the flow study, we can start working in Cortime. As usual, the first thing we will do is to set up some equations. If we open the sketch, we can see that we have 4 equations to modify the spline. So we have between the first and the second spline points, between the first and the mid spline point, and then between the last and the previous last spline points, and between the midline of the pipe and the last spline point. No, in the middle spline point. So once that we have set up the equations, we can, as always, use the equations, drag them to the optimization variables window, and set up some ranges for them to work. We have done all that, so we can just go and click on the design checker to be sure that the file rebuilds every time. As it can be seen, it is able to rebuild on every single time, so we can just continue, close the design checker. Now, usually the second step will be to set up some sensors and use those sensors as optimization objectives. But this is a particular case because we're working with a fluid simulation. So in this case, we're going to use these goals that we set up in the fluid simulation as objectives. So we will have a flow goals option in the optimization resources window. And in our case, we will use the surface goal volume flow rate. And our goal will be to maximize it. So our optimization consists on Cortime modifying these mirror splines to maximize the flow rate in the pipe. Now we can go to the optimize window. In display settings, we will have our goal already set up. And in the optimization settings, we will have everything as it is by default. So we will use the multi-objective, solution spaces, and now presets regular optimization. Number of sessions 1 and number of iterations will go with 650. So once the optimization is set up, the next step is to run it. Once the optimization process is done, we can take a look at the result. The first thing we can do is to take a look at the actual part. So if we zoom in, we can see that the spline that we modified through Cortime has changed a lot. We saw before that it depends on these mid and extreme points, and they have been modified. So now the spline is softer to make easy for the liquid to go in. So now we can take a look at the process graph. We can see as previously that in the beginning it looks random. So if we zoom in, right click, and we draw this rectangle, we see that the first points are kind of random, and that is because of the algorithm. In the beginning, it will move randomly through the solution space until it finds a good enough point, and from that point onwards, it will start optimizing. So we're going to right click out the scale ones to see the whole graph again. we see that it goes from the beginning, first random spots, and then it quickly raises up, and it reaches convergency around the 120, 140 iteration. And if we want to look at the values, we have the first value, it was 0.09, and the last value ends up in 0.124. So there is a huge rise in the flow rate. Now, if we want to take a look at the analysis tab, as we usually do, Cortime will tell us that it's not possible to show it because it needs at least two variables or two objectives or a combination of both to showcase it. So what we can do is to click in the X inside parentheses and then click on show, for example, all of the variables. So now we can take a look at the analysis tab. And what, for example, we can do is to reduce the range in which we can see the flow rate. So only let the maximum. So if we zoom in now, these are the iterations that fulfill those values. For example, between 120 and 122. If we click here, we'll have 120, and we can right click and restore iteration, and we'll see how it changes very slightly because we're really close to the point we were before. But if we click here in the right button and we out of range, we can reopen, and we can, for example, click here, and that will be one of the most extreme iteration because it goes when the volume flow is the lowest. So if we right click on it and we restore iteration, we see that the change is obviously very weird, and that is because we're manipulating all the points in the spline. So in the middle there can be a lot of weird shapes that it generates. Not all of them are going to be smooth. So if we want to look at the opposite point, that will be the 0.124, so the most perfect, so to say, point, and we restore it. We come back to the point in which we were before, that is very smooth. And we can take a look at iterations in the middle also if we want. And we see, yeah, there are a lot of weird shapes in the middle. This has been everything for this video, a small summary of how to set up a fluid optimization in Cortime. I hope you enjoyed. Thank you very much.